Hello everyone, we're going to be going through the second section in your notes from the probability unit, and we're actually going to start getting into probabilities here. So probability is a ratio comparing the number of desired outcomes to the total number of possible outcomes. The formula for it is right here, so any probability you're trying to find is going to use this in one way or another. So it's going to be the number of successes, the things that you want to happen, divided by the total possible outcomes, the total number of things that could happen. And there's two ways to look at probabilities. There is either what we call theoretical and empirical. So we're going to start with theoretical. Theoretical probability is when you calculate the mathematical likelihood an event will occur. So it's looking at the mathematics of it, not what necessarily happens exactly. That's empirical. So theoretical is just going based on what could happen. So looking at an example here using theoretical probability. A box of golf balls contains 3 yellow, 4 white, and 1 red golf ball. If Leroy chooses 1 golf ball from the box without looking, find the probability that the golf ball is, so looking at the first one, yellow. Well, we know there are 3 yellows, so that's 3 out of a total of, well, we have 3 and 4 and 1, and if you add those together, it gives you a total of 8. Part B, the probability that the golf ball is red. Well, we know there's only 1 red golf ball out of a total of 8. Part C, something that is not red. Well, we know that there are 3 yellows and 4 whites, so 3 and 4 gives us a total of 7 out of 8 altogether. And part D, the probability that the golf ball that Leroy chooses is green. Well, there are 0 green golf balls out of a total of 8. So that gives us a probability of 0. And this is significant because something that cannot happen has a probability of 0. And in mathematics, that's called impossible. So an impossible event is something that the probability of it happening is 0. So sometimes you're asked to look at the probability of more than one thing happening. So if we want the probability of event A happening and event B happening, we actually go ahead and multiply the two probabilities together. So you take event A, the probability of the first thing, and you take event B, the probability of the second thing, and you multiply them together. So at a school fair, the spinner over here represented in the diagram is spun twice. What's the probability it will land in section G the first time and in section B the second time? So we want the probability of G the first time, and then we want the probability of B the second time. And this notation is something we'll get used to. It's a probability, this is what the P stands for, and then what's in the parentheses is the event that we want to happen. So the probability of it landing in G. Well, you'll notice over here that the G section is 1/4 of the whole spinner. You will also notice that the B section, this bottom part here, is 1/2. So if you want the probability of G and B happening, you're going to go ahead and multiply those. When you multiply fractions, you remember you multiply the tops, and then multiply the bottoms. So you'll end up with 1 over 4 times 2 is 8 as your final answer. So that is the probability of multiple events. Now, that can get even a little more complicated. So if we have a box that has 5 blue pens and 3 red pens, and we pick one and then pick another one without replacing the first, it changes the probability of that second event. When you spin the spinner, you're not removing any sections, so it doesn't change the probability of any section. However, here, if we want to look at the probability of picking 2 things without replacing one of them, it changes the probabilities. So we want the probability of picking a blue and the probability of picking a second blue. So if we have 5 blue pens and we have 3 red pens, that means we have a total of 8 altogether. And there are 5 blues to start. So we go ahead, we pull one of those pens out, we pick our blue one, and now we only have 4 blue pens remaining out of a total of 7. So when we multiply these together now, we're going to end up with 5 times 4 is 20 out of 8 times 7 is 56, which is our final answer. So this is talking about picking things without replacement. If it says at any point that you do replace it, then it's just like the spinner where you would spin the first thing, nothing changes, you spin the second thing. That's with replacement. When it says without replacing the first, that's when you have to worry about the probabilities changing. So that's theoretical probability. Empirical probability is a little bit different. This is an estimate of how often an event happens based on an experiment. So you base this only on direct observations. And just like the probability when we're doing theoretical probability is the number of successes, the number of things we want to happen, over the total number of things that happen, this is very similar. This is talking about the number of times that your desired event actually occurs in your experiment divided by the total number of times you run the experiment. So looking at an example very quickly, this is actually pretty straightforward. So Chandra and Alexi rolled 2 dice 50 times. So that means that over here in this box, there are 50 results. And they record the results in this chart. What is the empirical probability of rolling a 7? So what you need to do is go ahead and look at how many times 7 shows up. So they're highlighted over here for you. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a total of 13 sevens out of, and it says up in the top here, that they roll the dice 50 times. So that's going to be 13 out of 50, which is our final answer. Now the theoretical probability of rolling a 7, we would have to figure out the total number of options that there are when you roll 2 dice. So on your first dice, you can get 1 through 6, so that's 6 options. And on the second dice, you can get 1 through 6, which is 6 options. So there are a total of 36 possibilities. Now, you need to figure out the ways that you can get 7. So you can get a 1 and a 6, you can get a 2 and a 5, you can get a 3 and a 4, you can get a 6 and a 1, you can get a 5 and a 2, and you can get a 4 and a 3. So there are 1, 2, 3, 4, 5, 6 ways that you can get a 7. So 6 out of 36. So I want you to think about this next part here. How do the empirical and theoretical probabilities compare? I want you to take a second, think about that, and write down your thoughts on part C. So pause the video after you've wrote a couple things down. Go ahead and resume playing so that you can move on. So if a pair of dice are rolled, what is the probability of rolling a 10 or less? So if they're asking you what's the probability of rolling 10 or less, that means that you want a 10, a 9, an 8, a 7, a 6, a 5, a 4, a 3, a 2. Right? You can't roll a 1 on 2 dice because you have a 1 and a 1 gives you at least a 2. So you want to know the probability of rolling each of these things. Now that's a whole lot. One thing that you should make a note of in your margin somewhere is that the total probability is out of one whole. So if you're looking at all of the events and you're saying this is going to happen, that's going to be a probability of 1. So rolling 2 dice, if you're going to roll them and you want anything to show up, it will be 36 out of 36. If we want to know what is the probability of rolling 10 or less, you could actually look for what's not in here. So not in here, what's the probability of getting 11 or a 12? Now that's a little simpler, right? So as we found in the last problem, there's 36 possible ways that you can roll 2 dice. What are the ways that you can get an 11? Well, on 11 you can get a 5 and a 6, or you can get a 6 and a 5. And the only possible way to get a 12 is by rolling a 6 and a 6. So that is 3 possible ways. So it's 3 out of 36 is the probability of getting an 11 or a 12. But that's not what we wanted. We were asked what is 10 or less. So the cool thing is you can actually take that 3 out of 36 and do the whole thing, 36 out of 36, minus what you don't want to happen. So 3 out of 36. And that will give you a total probability of 33 out of 36. And that is what your final answer would be. So you're taking the things you don't want, getting rid of them, and it leaves you, your leftovers are what you want to happen. So 33 possible ways to get a 10 or less. I would like you to try number 6 on your own. I will give you a hint that when it says right here, there are 2 colored dice, one red and one white, that is just extra information. It's not having any influence on this problem that has confused people in the past. I don't want you to get confused with that. So try that on your own. We will go over it in class tomorrow. If you want the probability of something happening or something else happening, it changes what you do a little bit. Instead of multiplying now, you're actually going to add. So you find the probability of the first event, and you add the probability of the second event. So if we draw a single card from a deck of cards, there's 52 cards in it. Find the probability that what is chosen is an ace or a king. So we want to find the probability of an ace, or we want to find the probability of a king. Well, as everyone knows, there are 4 aces in a deck of cards, so 4 out of 52. And hopefully we also know that there are 4 kings out of 52. So if we are doing an OR problem here, we are going to add those together. We already have our common denominators, so we're going to go ahead and add the tops, and you'll end up with 4 plus 4 is 8 possible cards out of 52. So your probability of getting an ace or a king if you're drawing a random card is 8 out of 52. If we select a card and we want to find the probability that is a 3 or a heart, this changes just a little bit because there's a whole bunch of, there's 4 threes, there's a whole bunch of hearts, and there's one card, right? You have the 3 of spades. Oops. The 3 of spades. You have the 3 of diamonds. You have the 3 of clubs. And you have the 3 of hearts. And then you also have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And these are all going to be hearts, right? Now, the reason that we have to be careful here is because we have the 3 of hearts listed here, and we also have the 3 of hearts listed here, so it repeats. So we're going to find the probability that we get a 3, as we just found over here, that there are 4 options, so that's 4 out of 52. We want the probability that we have a heart, and as we see here, that is going to be 13 out of 52. But we have to take into account that there is something that happens in both of those lists. So the probability here that we get that one is 1 out of 52. So that's the probability that we get 3 of hearts. So what you're going to do is add your first 2, and you're going to subtract the last one. So again, we have common denominators here already, which is great. 4 plus 13 minus 1 leaves you with 16 out of 52 for your final probability. The last two things here. Sometimes we need to use permutations or combinations to determine the number of desired outcomes. So, the letters of the word cabin are rearranged at random. What's the theoretical probability, and that's important, theoretical probability, we're not doing an experiment, that one arrangement chosen at random will begin and end with a vowel. So remember, we want to know the number of ways with vowel at start and end, and we want to divide that by the total arrangements. So I need you to think back. If we're looking at the ways to begin and end with a vowel, well, we know that C-A-B-I-N is 5 letters. There are 2 vowels here. There's an A and an I. So if we want to start with a vowel, that will leave us with 2. And if we want to end with a vowel, we need to put that other one at the end there. So our other one would go there. Now, you also notice that C, B, and N are in there. So our second choice here, we would have 3 choices, followed by 2 and 1, and you are multiplying all of these. So 2 times 3 times 2 times 1 times 1 actually gives us 12. And on the bottom, we want to find the total number of arrangements. So we want to do 5P, because the order does matter, 5. So 5P5 gives us 120, 5 times 4 times 3 times 2 times 1, which actually you can reduce that one down, and it will give you 1 out of 10 as your final answer. The last thing I'm going to ask you to do on your own here is go ahead and give number 2 a try on your own. They need 2 seniors to head the November blood drive. There's 12 volunteers, 4 boys, 8 girls. What's the probability that 1 girl and 1 boy will be chosen to head the drive? So I'll give you a small hint. You're going to need to find the number of boy choices. And then you're going to need to find the number of girl choices. And then on the bottom, you're going to need the total choices. We are going to go over that in class tomorrow, so pause the video, give that a try on your own. And the last 2 things here, examples 1 and 2, we're actually going to finish in class. We're going to do these together, so make sure that someone reminds me that number 1 and number 2 we will be going through as a group in class tomorrow. I know this video was a little long, I apologize that. There were a couple things you need to attempt on your own that we will quickly review in class, and then we have a couple more examples to go through, and then we'll do some practice. I hope you have a wonderful evening, and I will see you mañana.